My name's James Bezic. I'm a Senior Developer Advocate here at AWS Serverless. This series is about the S3 to Lambda serverless design pattern and how it can become a flexible core for your serverless applications. This video shows how you can bring automated natural language translation into your applications with minimal code. This solution uses Amazon Translate to automatically convert between dozens of different languages. This can be useful for many applications. For example, for public websites, you could translate dynamic content like product pages for international visitors. Or if you build mobile applications, you could translate resource files when new builds of your software are available. If you have customer support channels across different languages, you could use this approach to translate back to a common language. Let's look at how this works. So the first thing I'm going to do is git clone my code repository. I'm going to cd into the directory, and then we'll just look in the first example, translation. Here we've got two template YAML files. I'm going to deploy the first one, so while it's deploying, I can talk about the code. I just run sam deploy and use the new guided deployment. For the stack name, I'll call it translation v1. I'm in US West 2. It takes a list of parameters for languages. We'll leave those to be the same. And then the bucket name I'll set as jbezwer translation 1. And then I'll just accept these defaults. Okay, that's now deploying. So if we take a look at the code, you'll see there's two functions here, a batching function and a translation function. And in the SAM template, this is what we have. First, in the parameters part at the top, there's a target language for our translation. We've got French, Spanish, and Italian here, along with a bucket name that's a default. Further down, we can see there's the translation bucket using that bucket name. And then there's a translation function that specifies where the code lives in that directory there. And it's a Node.js application found in app.handler. It uses 128 megabytes of RAM, and it takes an environment variable of the target list of languages. Here it also specifies the IAM policy that the function has, and also how it responds to the event in the bucket, looking for .txt files to perform the translation. Okay, so app.handler is where the code lives. So let's take a quick look at this. This is a standard Lambda handler. We have a list of supported languages at the top just for ease of use. Then when the handler starts, it can be handed an event with multiple objects. So the first thing it does is goes through and iterates through a list of all of the different files that are handed in. It then calls do translation, which further down, do translation looks in the S3 object and retrieves the list of text. It then calls translate text, which is really just a wrapper, and then it puts the object back in S3 in the translation subfolder. Okay, so let's test this now. We'll go to the bucket, and I'll look in the translation 1 bucket. There's nothing in there right now, but I'm going to upload a simple text file, coffee.txt. It just has one line of English in there saying I like coffee. So I'll drop that in there and upload this object. That's now uploaded. And if I now refresh the contents of the bucket, you'll see there's now a translations folder that's appeared, and it has these 3 different translations for English, French, and Italian. I'm just going to make these public so we can take a look. And I'll open the French translation, and you can see, Bonjour, je m'appelle James. It's my comment in French. And you can see the other translations there. Now back to the main bucket, if I upload more than one file at once, I've got several different text files I can use, some with some longer examples. I'm going to upload those all now. Okay, those are uploaded. If I look in the translations folder and just refresh the contents, you can now see all of these other translations have appeared in French, Spanish, and Italian for all those different files. And again, I'll just make one of these public so we can look at the Las Vegas one in French. And there you can see that text snippet has been translated by Amazon Translate. In this example, you can see how this application can process large numbers of files in parallel. Regardless of how many text files are put into the S3 bucket, Lambda will scale up the function to do the translation. The whole application is under 100 lines of code, but can already handle an enterprise-level amount of data. This example shows how to translate smaller snippets of text, up to 5,000 characters in size, which is the limit on the single request to Amazon Translate. But what if you need to translate much longer pieces? Well, fortunately, that's fairly simple too. I don't need to change the first application at all. I can create a second bucket to receive a larger text object, and then create another Lambda function to break it into smaller pieces and store in the original bucket. This demonstrates how you can chain the output of one function to the input of another function using an S3 bucket as an intermediary step. Let's take a look at the code. So the first thing I'm going to do is build this second template for this second application using the sam build command. This just runs npm install on all of the functions. Once we have this, we can now run sam deploy on this second template. Put template v2 using the same guided approach as last time. I'm going to use the stack name and the region it's provided, and also the target language will stay the same, but I'll give it a bucket name of jbezwa translation, and the batching bucket we'll use as jbezwa.batching, and I'll accept these defaults for the rest of the deployment. Okay, that's now deploying. So let's take a look at this second template. This is very similar to the first one. You still have the target language and the bucket names, but now there's a batching bucket we'll be using. And you can see it's specified there in the resources. Now the translation function is identical to how it was before. And then further down, there's now a batching function, and it's getting the code from batching function subfolder, and it's going to fire when it receives a txt file in that bucket. Let's take a look at the Lambda handler in app.js. So this is a standard Lambda handler. Again, it will receive an event with all of the different objects, so we'll iterate through those objects and then call do batching on each one. Do batching is really a wrapper for an npm package that can split up chunks of text using sentences. We're just using that to pick up 10 sentences at a time. And then once it's finished batching those up, we put those back into S3 using the S3 put S3 object function. Okay, that deployment is now completed. So let's take a look at how this works. I'll look for that second batching bucket that we've created. I'm going to upload a larger example. I've got an example from War and Peace, a fairly long novel. I'm going to bring this in and upload that. Okay, so that's uploaded that section. So if we go back to the translation bucket, and I'll just refresh the contents, you'll see that it's broken up War and Peace into all of these different sections for us in the batching process. And now in the translations part, you can see there's English, French, Spanish, and Italian also appearing there for each one of those sections. And if I just open up one of these as an example, there you can see 10 sentences of War and Peace in French. Combining the S3 to Lambda design pattern with other AWS services can open the door to really innovative solutions. In this case, I used Amazon Translate to convert text into potentially dozens of different languages. Since the service handles the scaling, it can process hundreds or thousands of lines of text in parallel. Our Lambda function contains only the minimal business logic to connect the services. Using the serverless application model, setting up a deployment package with AWS resources in our code is very straightforward. To download the examples from this video and others in the series, visit this URL. Thanks for joining me for this walkthrough. I hope to see you on the next video. Happy coding!